Hello all. Today I will discuss about depletion type MOSFET for N-channel only. In the previous class I have discussed about enhancement type MOSFET that is also for N-channel only, right? So at first we will talk about the construction of depletion mode MOSFET, right? Now the basic difference about the construction between enhancement type MOSFET and depletion MOSFET is, see here, this is enhancement type MOSFET and here we have to create an N channel to pass the current ID from drain to source. This is for enhancement type MOSFET. Now in case of depletion type MOSFET, what we can see that there is already one channel is created between two N walls, right? You can see here already one channel is created between two N walls. So this is the basic difference between enhancement type MOSFET and depletion type MOSFET, right? About the construction. Now after this construction we will discuss about the working principle of depletion type MOSFET. How is the depletion type MOSFET is working, right? So here you can see the same construction like in enhancement type MOSFET. There is one VGG and one VDD is connected. The VGG is connected to the source and ground, and there is also 4 terminal, but here the source terminal and the substrate terminal is internally connected. So here we can consider only 3 terminals, right? So here is source terminal, gate terminal and drain terminal. Now the VGG is connected with the source and gate and the VDD is connected with the source and drain, right? Okay. Now, in case of enhancement type MOSFET, what we can see that we have to create one N channel, right? So for creating N channel we have to enhance the value of VGG, so the holes will be pushward downwards and the electrons will be go upwards, that will be attracted and there will be one N channel is created. But in case of depletion type MOSFET we don't have to create any type of N channel because N channel is already created. So when VGG is equal to 0, that means we do not enhance or decrease the value of VGG. Then if we enhance the value of VDD, that means the value of VDD, if we increase the value of VDD, what will happen? The current will pass from drain to source in by this N channel, right? Now after increasing the value of VDD, the current will pass from this N channel, but one time will come as we can see in JFET. One thing as a reminder, you can think that the operation of depletion mode is as similar to JFET operation that we have discussed in the previous video, that the construction of JFET, similar types of construction and similar type of working principle is also in this depletion type MOSFET, right? How this is possible? See here, when VGG is equal to 0, right? When VGG is equal to 0, then when VDD is increasing, so current will also increase it. But we have known in case of JFET that there is also a counter effect of increasing VDD. What? That there will create a reverse bias, so that there will be a reverse bias. For reverse biasing, there will depletion region will increase and the current will saturate one time, as the same case for JFET, right? Now how the depletion region is created, you can see here where this is the drain terminal is with positive potential and here is the N channel. So what we can see, the N channel is connected with positive potential and the P type substrate is with the negative potential. So here the reverse biasing will be more and more, so the depletion region will be also more and more. So because of the increasing of depletion region will decrease the amount of current from flowing to drain to source, and one time will come that is the pinch of voltage. We have seen in case of JFET that in the pinch of voltage the current will saturate, right? Now what is the difference between the value of the maximum current, right? Now in case of JFET we have seen that the maximum current for JFET is when the pinch of voltage come. When the pinch of voltage come, then we will get the maximum current, and after that the current will saturate, right? But in this case, when the pinch of voltage will come, the current will saturate, we can consider. But that is not the maximum current, because there is also one voltage you can see here, that is VGG, right? Now, in case of JFET, you can remind that in case of JFET, we only considered about when VGS equal to 0 and when VGS less than equal to 0. That means when VGS equal to 0 and when VGS less than 0. We have discussed only about these two cases, but can you think that we have discussed about when VGS larger than 0? No, because that is not possible. Only possible the possibility for JFET is when VGS equal to 0 and when VGS less than 0. But in case of depletion type MOSFET, we can increase the value of VGG also. And because of this reason, the maximum current will not at the moment of pinch of voltage, right? Because when we will increase the value of VGG, then the pinch of voltage will come later, so the maximum current will also increase and the saturation time will also come later, right? Okay, so this is the basic difference between the JFET and d-MOSFET about when the operation will work in these two cases, right? Okay, now let us consider when VGG is less than 0, right? Now we have already discussed when VGG is equal to 0, then what is happening? It's the same thing as JFET, but when is VGG less than 0? When is VGG less than 0, then what will happen? Now you can see here. Let us consider this VGG is equal to here minus 1 volt, right? So because of there is minus 1 volt, so the G terminal is that means the gate terminal will in negative potential, and there will be a negative potential will more and more. So what will happen, that there is, we can see there is an n channel. So here the more concentration is about electrons, free charge electrons, right? But because of this negative potential, the electrons, charge carriers electrons will repel this terminal to each other, and this will push down. Similarly, the vice versa, the holes will come upwards because the negative potential will attract the holes, because holes are positive charge carriers. So the negative terminal will attract the holes and the holes will come upwards, right? So what will happen? The free charge carriers and the holes will recombine each other, and after the recombination, the n channel behavior will decrease, right? In the n channel behavior will decrease, and the behavior of positive charge carrier will more and more. So what will happen? The value of current which will flow from drain to source will decrease also. That means when VGG is minus 1, but the value of VDD is same. That means when the value of VDD is 0, but the VGG is minus 1. So what will happen? The value of current already will increase. But in case of VGG equal to, when VGG equal to 0 and when we will increase the VDD, that the value of current will greater than the value of when VGG is less than 0. That means then you can consider when VGG equal to 0 and we are increasing VDD. So that time the value of current will greater than when VGG less than 0, and that time we will increase the value of VDD, then the value of current, right? This time when the holes region and the positive charge region will more and more here, that time the value of current will be decreased, right? This will be cleared more when you see these drain characteristics of depletion type MOSFET and for enhancement type MOSFET also. So what we can see that this is the VGS, the this is the VDS, the value of VDS. This is the VGS, this is the VGS value, and this is the ID current value, right? So we can see here the more standard region, that means when VGS equal to 0 volt, then what is happen? One time the current will saturate and the saturation region will come. Now when the value of VGS is decreased, so the value of current is also decreased, you can see here, and the saturation region will come very earlier than the standard mode, right? So this mode is we will call depletion mode. Similarly, when we will increase the value of VGS like 0.5 volt, 1 volt, 1.5 volt, that is the enhancement mode. That means the value of current is increased here, because we have known in the previous day's video that in enhancement type MOSFET, when the value of VGS is increased, so what will happen? The holes will push down and the electrons will create a n channel between two n1s, so the n channel will become big and the current will pass from drain to source more and more as the VGS value will increase, right? So this is the enhancement mode and this is the depletion mode, and that is the drain current that will increase or decrease in two regions. So I hope you can understand the two differences, that what is the difference between depletion mode and enhancement mode, right? Now to basic points that we have already discussed, that working of d-MOSFET is similar to JFET. I have told that why I have written that working of d-MOSFET is similar to JFET. I hope you have understood that, and the difference between e-MOSFET and d-MOSFET. The basic and the most important difference is, I have told that in case of enhancement type MOSFET, no channel is created. We have to create the channel by increasing the value of VGS. But in case of d-MOSFET, already the N channel is created. So in case of VGS equal to 0, the current will also pass with the increasing value of VDS between drain and source, right? So this is today's lecture. This is all about today's lecture. I hope all of you have understood that the depletion type MOSFET. So from the next day, we will start a new chapter that is called op-amp, right? So the electronic students, I hope they have already studied about op-amp, and we will discuss about the basics of op-amp in the next day. So this is the lecture of depletion type MOSFET. For any type of query, doubts, please write in the comment section, and you can also mail me in my mail. I will write in the description box, right? So for today.